Good morning and welcome to D3 Technologies 3D Systems um, Manufacturing the Future Now. This actually is going to be about tooling, which is not just for the traditional methods. We'd like to take some time just to talk with you a little bit about how 3D Systems and D3 Technologies uses the 3D Systems tooling application for 3D printing today. I'm Barb Miller-Webb, and I'm with D3 Technologies. This will be about a 3-minute presentation. So, thing, I want to tell you just a moment a little bit about D3 Technologies. D3 Technologies actually is partnering with 3D Systems, who's the manufacturer of 3D printing. And we started this partnership with 3D Systems several years ago. The reason why we chose 3D Systems is because of their breadth of products. They actually have so many various technologies to choose from, and also because they truly are the leader in this 3D printing world. They are the innovator of 3D printing, which started about 30 years ago with Chuck Hall, who's still the um, principal at 3D Systems today. And so that's really where 3D printing evolved, was from 3D Systems stereo lithography technology. He also invented the STL file, which is the standard file known for exporting out files from your CAD into the 3D printing printer itself. So, who is D3 Technologies? Well, first of all, we are a trusted advisors and we do help manufacturing companies become more successful by optimizing their manufacturing solutions and services. We do this all through our people and our various processes by leveraging some of the latest engineering and design technologies. So that could either be through our support, could be through our training that we offer at D3 Technologies, could be some of our one-on-one mentoring, or possibly some of our services such as automation, things of that nature. D3 Technologies offers various various softwares within the Autodesk world, such as simulation, plant, factory, and many others. In addition, D3 Technologies, of course, has 3D Systems printing solutions and their scanning solutions as well. We also represent a CAM package for the manufacturing side, and finally, we also have the CNC machining shop that we offer for some low volume runs. Again, our whole methodology is really just to help manufacturers through some lean engineering processes. And the whole point is to help you as a manufacturer increase your revenue and reduce your costs. Here's what I want to do today. I want to talk a little bit about product realization, but we're going to focus on rapid tooling. And I think you guys have heard me say this before, that in the past, there's really 5 major categories that has to do with 3D printing, and we really group these into these 5 categories, if you will. So again, communication just allows you to really communicate with a 3D printed model to your customer or maybe to your internal groups. Then there's also the next category called functional or validation. This is where you can actually do true testing, maybe testing with air, possibly testing with fluids of some sort. The nice thing about some of our products, some of the materials are a watertight, airtight solution, or maybe just form fit through functional testing, if you will. Then the third category, rapid tooling, which we're going to talk about today. Again, part of the pre-production process, if you will, being able to do various types of tooling, jigs, fixtures, things of that nature. Fourth is your end-use parts, or your true end-use production parts, or what I call additive manufacturing. So it really allows you, 3D printing is where you simply is called additive manufacturing. So it's really growing your part as opposed to maybe your traditional method of using CNC print machines where you're using more subtractive manufacturing. And lastly, custom or mass customization. This is where you're actually able to use 3D printing to do specific customized products. If you think about it in the dental world, you're thinking about, various bridges, things of that nature that is actually done with 3D printing. Um, so it does allow you to do some major customization. Let's move on and let's talk a moment about rapid tooling. The whole point of rapid tooling is it really is faster time to market. You can do fast patterns and mold printing much earlier in your whole launch process. So as product development coverages on the final design, your attention really does turn to the manufacturing startup. This stage often kind of involves significant investment in tooling. As you know, it's not an inexpensive process, or even could be expensive in the way of jigs and fixtures to help manufacture the new product. So again, at this stage of rapid tooling, the supply chain typically expands with purchase commitments for raw material or some other components, and lead time for these required items can stretch out time to market with your product. And so 3D printing really, in a variety of ways, helps reduce that investment risk and helps you shorten your time cycle for launching a product. So the whole point is to really reduce that investment and kind of start your process validation before the final tool production process begins. Processes that really benefit from 3D printing are listed right here. Injection molding, jigs and fixtures, RTV molding, hydroforming, thermoforming or vacuum forming, and as well as investment die casting. So this is kind of a recap of all the rapid tooling processes in which 3D printing solutions are used to reduce your time and costs to produce your parts. For those processes, 3D printing can provide the master pattern, which is kind of the sacrificial pattern or the mold itself, in really just a few hours in most cases. And 3D systems printing solutions offer really great accuracy, fine details, and sharp edges, as well as surface finish, and some of the appropriate material properties. Material properties play a big part in this that really helps surpass complexity capabilities of your traditional methods using CNC equipment. So again, your injection molding or your direct mold production can be accomplished from plastic or from metal 3D printing with integrated cooling channels. For your jigs and fixtures, those are really custom 3D printed jigs and fixtures. And then, of course, RTV molding allows master pattern production for RTV molding. Then you've got hydroforming, which is really a direct die mold production or negative mold printing for epoxy tool pouring. Thermoforming, vacuum forming, I'm sure that everyone sees those blister packs out there, which 3D printing can be used for to produce direct molds or pattern productions. And then, of course, foundry or wax pattern and mold production. So those are all areas that tooling processes really do benefit from the use of 3D printing.
3D printing is really a tool that's become available to the masses, and I think it's got people thinking about things again. We've used our 3500 HD Max to print injection mold tooling. We currently have 3 of the 3500 HD Max machines in the organization and expect to buy more. It's really helped us tremendously in terms of being able to help our customers do more faster.
Traditionally, you want a molded part, you buy a metal mold. It'll take 2 to 3 weeks to make it. It'll cost $6,000, $7,000 depending on the part. We were able to take the exact same part and take the manufacturing time for the mold from 2 to 3 weeks to a day, 12 hours. If we get files in the afternoon, we can't ship parts the next day. This particular part The customer's usual cycle for tooling was 2 to 3 weeks to get a sample. After they released the order for the tooling, it was 2 to 3 weeks. We did 4 passes of this part, 4 tests at the customer in about 6 days, and that included shipping. So the customer doesn't have to make concessions in his design, doesn't have to cut corners, doesn't have to wonder would it really have worked if we had done it this way. Any part that we would want to do, we've been able to do with printed tooling. That's one thing with the 3D printers. It allows us to create things that you would have just imagined.
So this company is actually BioLink. BioLink is a customer of 3D Systems, and I really wanted you to see this because they're a very good example of just exactly how injection molds are being done today with 3D printing. And as he mentioned, you know, your time saving on this particular example, an injection mold was done in 12 hours versus 2 to 3 weeks for a metal mold that typically will cost you $6,000 or $7,000, sometimes more, sometimes less, depending on what it is. And in this example, they produced 4 printed mold iterations in only 6 days with 3D printing. Customers can actually modify their parts, improve their products without the hard tooling costs and lead times. So the materials with 3D printing actually withstand upwards of 10 tons of pressure. And with this technology, which is actually multi-jet printing technology, injecting at a temperature at about as high as 337 degrees, or excuse me, Celsius. Um, High quality to produce those actual production parts, really just allowing tiny little features. So it allows you to get more complex shapes more easily than with your metal tooling undercuts and inserts. Oh, hard tooling molds. Hard tooling production really can be accomplished with our direct metal printing. This is 3D Systems direct metal printers. The beauty of this is you can really design, as I like to say, complexity is free with really no geometry limitations, right? And it's certainly much faster than your multi-step CNC. So in this example, this is actually built on our direct metal printing, the Pro X 300 from 3D Systems. It's 12 inserts that were printed in about 50 hours. If you'll notice, they got very smooth vertical walls and with special build style. So the undercuts are there without any supports needed. This example, this is an engine development example, and there's a couple of them here. Um, First of all, we've got with our multi-jet printing technology, Honda, and in this example, it actually reduced the design to manufacturing by about 4 weeks. So with more design iterations from your CAD to your metal parts in 2 to 3 weeks. So there really was no need to create injection wax tools. More improvements were able to be incorporated into that design due to the additional iterations. So they were able to get improved engine reliability with no design limitations. It reduced up to 2 weeks of the design time by eliminating the need to incorporate draft and remove any undercuts on the components. Then there's also another one with the Honda's racing company within North America. Honda Performance Development is a single engine supplier to the Indy Car Series, and they lease engines for prototype sports car racing in the American Le Mans Series, or the ALMS, as most people know it, and the European Le Mans Series too. So their challenge was basically in 2009, HPD started a feasibility and concept study on taking a V6 engine from their production vehicles to run into a race engine. And in 2010, the concept had become the Honda Racing 2.8 liter twin turbo engine project. So Honda had only about 11 months to make that 2.8 liter twin turbo perfect. So they used our 3D systems, Projet, what we call our CPX, so it's our our Multijet printing technology, to allow Honda to change their designs on the fly and deliver metal parts faster to eliminate the time to um, designs due to their traditional manufacturing methods. So again, perfect way to use real wax casting patterns and save a lot of time and money on tooling. So this is another good example, a complex gearbox housing that's actually used. This is, again, allowing us to use our design freedom in those complex details to get better performance. And there's two different applications here. On the left, you've got the SLA quick cast patterns that can be used, and also the aluminum casting of a gearbox housing. So in this case, there was really no negative implication, no extra cost to really adding the complex details. There was no conformal cooling channels, or excuse me, there are some conformal cooling channels that are running through the housing. So that really makes it impossible to make with your traditional techniques of CNC technologies. Here's a same day hydroforming tool. This is a great application when you're talking about hydroforming. In this example, a die mold was actually printed in 6 hours, and after 100 pieces were formed on that, you still didn't see any wear and tear. You still saw the superior finish, and it's really low investment. This uses our multi-jet printing technology, and what you're getting out of this hydroforming is you're getting strength because our materials, our VisiJet materials, stand up to extreme pressure at about 5,000 psi for hundreds of runs in this example. You're also getting tool surface quality. You get smooth surfaces and accurate edges of the tool to make a true to CAD design part every time. And in all honesty, these tools that were built on our competitors' machines had thicker layers and they were leaving layer lines on the finished part, which you just can't have. So it really allowed you to have quick design and print with a variety of tools in one build. You can use custom form metal pieces in hours versus days. So it really does save you a lot on time and money. And this is an example of that same day hydroforming being accomplished on our 3500 series. So you notice that we moved the hydroform aluminum part, and you can repeat that process as many times as you need to on that 3D printed part, which happens to be done on our multi-jet printing technology. But the beauty is you get tooling in the same day. So imagine being able to create a design and go out and produce a 3D printed tool and start that tooling the same day. Let's turn to another portion of rapid tooling, and that is being used for assembly jigs. Assembly jigs are another great way for rapid tooling. In this case, this happens to be a customer of ours, Citizen Watch. And in order to maintain their confidential development strategy, Citizen really relies on their in-house prototyping division. So before they ever got their 3D systems multi-jet 3D printer, Citizen used NC lathes in their machining center to create mock-ups of final watch designs and assembly jigs. And obviously, because this type of machining frequently adds your costs and timeline delays, Citizen decided to explore their options into 3D printing and reduce their time and money of their development center that they spent on prototypes. So their challenge was really improving their assembly jigs, which was typically a 20 to 30 day process at Citizen. And so obviously it was very costly. So they started, their solution was really to invent a new assembly jig. And before getting their 3D printer, they produced one variety of assembly jig. But after they obtained their 3D Systems Multijet printer, Citizen has treated the new jig candidates, enabling Citizen to make best suited shapes for required fits in the shortest amount of time. So their ProJet 3500 Multijet printer transformed their 20 to 30 day process into an overnight production. And it's really been seamlessly incorporated into their whole workflow process as a development tool today. So again, another way, this is using direct metal mold productions with our 3D printing metal printers. And you can also use direct plastic mold productions with our stereolithography, SLA, and our multi-jet printers, which are 3500 and the 5000, both. So at a fraction of the time and costs, you can do this today with these injection molds now versus the traditional method. Obviously, you're going to get excellent accuracy and surface finishes, fine details. Because of this technology, you can actually get high impact and temperature resistance plastics. For direct metal, you get higher volume production. You get, again, complex shapes such as undercuts, inserts, integrated conformal cooling channels, and it's really fast, easy, and it's really repeatable, which is all key for some direct mold. And your on-demand jigs and fixtures you can do with our 3D Systems stereolithography technology for plastic parts. And then also the multi-jet printing you can do as well. Again, either whether you choose SLA or MJP, you're still going to get the ability to do on-demand, customized, without tooling costs involved. So if you're trying to get master patterns and die molds, you can accomplish that from very small, minute pieces to high precision master patterns and die molds, again with either our stereolithography or our multi-jet printers, 3500 or 5000 series. These are really used for RTV molding. It's also used for hydroforming. Both these technologies are used for thermoforming, vacuum forming applications. You find a lot of this in the dental application, as I talked about. Um, Invisalign, as you guys might be aware of, is clearly using our multi-jet printing technology for printing those Invisalign products out on a daily basis to the tune of about 100,000 per day. If you want to talk about wax casting patterns, 3D Systems offers the wax, real wax patterns that can be produced. With high resolution, you can get high accurate patterns, and then you can cast directly using your standard casting processes. So just imagine, again, being able to go from your CAD model to a wax pattern to finish cast metal part in a couple of days instead of a couple of weeks. So obviously, 3D Systems has got some great solutions to help you adjust your specific requirements with a selection off of our printers with the high resolution and the build volumes and the various wax materials to address your range of casting applications. So using the 3D printed patterns in your standard lost wax casting process and equipment. So again, why do you want to choose this process, which a lot of people do use for your jewelry applications as well? Again, because you get superior quality with wax patterns, you get high resolution, sharp edges. It's really intuitive and easy to use, and you can include that in your rapid workflow and improve your casting room efficiency and productivity right out of the gate. We have, if you're trying to do something very precise or small for direct casting patterns, we have another unit. It's actually our ProJet 1200 if you're trying to do micro SLA quality. Or we've got the ProJet 3500 more for direct casting patterns if you want high definition with ease. Or we've also got the stereolithography SLA printers to print the most complex shapes and intricate details from very small to very large casting patterns. Really, there is no limit to what you can do with rapid tooling today. We've talked about some various applications, whether it was hydroforming, cast patterns, um, injection molds. So really, you've got various applications from the various technologies of 3D systems. And so now that you guys have the tools are here for 3D printing. So now it's really your turn to take it and start using 3D printing in-house to accomplish and allow you to reduce your costs and maximize your productivity. Thanks. I appreciate your time, and we'll see you on the next session.